then I am trying to find solutions that make this true. So I'm asked to solve, I'm asked to find solutions that make this a true statement. These are not identities. I'm just trying to find numbers, in this case angles, that make these true statements. So if I have cosine of x is equal to some number, and these will be on the unit circle. If I have cosine x is equal to some number, if that number is 1, negative 1, or 0, then I know it's going to be a multiple of pi, or pi over 2. Because that's where on my unit circle cosine is equal to negative 1, 1, or 0. If I'm asked to find a cosine for a that is not equal to 0, but it's in that interval, then I look on the unit circle where those are true. If the number is not on the unit circle, then I just do the inverse of it in my calculator and make sure I'm in the correct unit. So as an example, if I'm trying to find for the cosine of x is equal to negative square root of 3 over 2, I get my unit circle out and I look to see where the x values are equal to negative square root of 3 over 2. So where are my x values on my unit circle? Everyone should have their unit circle out. Where are my x values on the unit circle equal to negative square root of 3 over 2? Okay, so the first time it happens is when x is equal to 5 pi over 6. And every multiple of that plus 2 pi k. Remember that whole coterminal stuff? That's this. Every angle that is coterminal to 5 pi over 6 is also going to be a solution for this. Where else is this thing equal to negative square root of 3 over 2? So 7 pi over 6 plus 2 pi k. Every angle that is coterminal to 7 pi over 6 or 5 pi over 6 are going to be true. Everyone that's coterminal. That's why we learn coterminal. So like I said, this section brings everything in that we have learned in chapter 10. Everything comes to a summation here. So with your partners, try doing B. So for B, where is the cosine of my angle equal to the square root of 2 over 2? Pi over 4, and where else? So this one is equal to pi over 4 plus all coterminal angles to that, and 7 pi over 4 plus all coterminal angles to that. Does that make sense? Cool? So if it's on the unit circle, you find it on the unit circle. If it's not on the unit circle, then you just do the inverse. But remember where the inverse lands. So if you were doing the inverse and you get an answer that's positive, don't forget when you're doing the inverse, it actually could have happened in quadrants 1 and 4, but the inverse is only defined between 1 and 2. If the solution shed is equal to 1, then it's just multiples of pi, actually multiples of 2 pi. If it's equal to negative 1, it's multiples of odd multiples of pi, so pi, 3 pi, 5 pi, 7 pi. If it's equal to 0, it is pi over 2, and then multiples of that, that should be pi over 2, not 2 over pi, pi over 2. Plus multiples, so pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative 13 pi over 2. And if you get something that's like this, it says, hey, find this solution. The cosine of x is equal to 7. We know that doesn't have a solution because all the outputs for cosine is between the interval negative 1 to 1. So this one has no solution because this value has to be within the range of cosine, and it's not, so it's a no solution. Now, if I asked you to find one that does not have on the unit circle, if I asked you to find the cosine of x is equal to 0.73, this is where you take the cosine inverse. So go ahead and find that in degrees. Make sure you are in degrees to 1 decimal place. So give me the solution to that, because that is not on the unit circle. Give me the solution to that to 1 decimal place. So x is equal to 43.1 degrees. What do I need to add to this, though? Plus 360k. Now, here's the thing, though. The other place the cosine could have been a positive 0.73 is in which quadrant? 4. So how do I find that in quadrant 4? How do I get the 43.1 in quadrant 4? Yes? Absolutely. So if I take, to find the second one, what I'm going to do is I'm going to take 360 degrees, I'm going to subtract off 43.1. And the reason I'm doing this is because I need to be in quadrant 4. So 360 minus 43.1 is what? 3, what is it? 316.89? 316, okay. I was like, how did that happen? Okay. And then what do I add to that? Plus 360k. If it's on the unit circle, it's so much easier because I can just see it on the unit circle. But if it's not on the unit circle, you've got to remember where cosine is positive, and when you do the inverse, what answers it's given you. So you do have to be aware of cosine inverse where it is defined and where cosine is positive in general. So there are two things going on with this one. Yes?
Would there ever be a situation when we get the exact value of that in degrees, or would it just be find it in degrees or be decimal?
So the only way you're going to get an exact number is if it's if one of these here is a nice number or give it a known number. It almost never happens. Yes?
I'm sorry, why is this in quadrant 4 isn't cosine in quadrants 1 and 2?
The inverse is, but cosine is positive in 2 quadrants. So if you take the cosine, do the cosine of 316.9, do you get the 0.73? So there are two things going on here. One is when you do the inverse, it's gonna default you because it's a positive 0.73. It's going to default you into quadrant 1 because that's where cosine inverse is defined. But cosine produces positive answers in quadrants 1 and 4. So you have to deal with the fact that we have 1 and 4. Now, when we did these, if you put this in your calculator in degrees and you do the cosine inverse of square root of 2 over 2, it's only going to give you the 45. It is not going to get you the 315. Does that make sense?
Yeah.
Okay. Did that answer your question?
Yep.
Okay. So similarly, when we're talking about sine, is we can do the inverse if it's not on the unit circle. But remember, when you are using sine and it's not on the unit circle, you have to chase where sine is positive and where sine is negative as answers. Because when you do the inverse and you're not using the unit circle, it's only going to give you one of the 2 possible answers. So when sine is 1 or negative 1, then we know that we're at straight up pi over 2 or straight down 3 pi over 2. If sine is 0, I'm on multiples of pi. So if you are using the sine inverse and it is not a given unit circle value, then you have to do like we did with cosine, which I'll give you an example of. But first, go ahead and answer these. So look on your unit circle. Determine where these are true for sine. So on A, raise your hand if you can tell me what you have for the angles that satisfy that. Yes?
45 degrees
What was the other one?
5,
And then because I want all real numbers, I have to go beyond just what's on the unit circle, and the way I do that is my coterminal angles. So plus 2 pi k, and then plus 2 pi k. If I only want it in the unit circle, my answers would have just simply been 4 pi over 3 and 5 pi over 3. But if I want all real numbers, I have to do everything that's coterminal to those two angles. Who'd like to give me B? Raise your hand if you can give me B. Matthew?
5 pi over 4 plus 2 pi k, and 7 minus 4 plus 2 pi k.
How are we doing? All right. Now I want you to do this one with your calculator. Do this in degrees to the nearest whole degree is what we'll do this time. So solve this one to the nearest whole degree. So when you solve for this to the nearest whole degree, what do you all get? Negative 22. Plus, and what am I going to add to it? 360k. Now that satisfies it in quadrant 4, because that's where my inverse is defined. Where else is sine going to have a negative answer? Quadrant 3. So I also have to find the one that satisfies quadrant 3. How do I find the one that satisfies quadrant 3?
180 minus.
Not 180 minus, it's 180 plus 22. So I have to find the one that's in quadrant 3, and quadrant 3 will be 180 plus that 22. Because if I do 180 minus, then I am actually in quadrant number 2. I need to be in quadrant number 3. So it's 180 plus that 22. So I do 180 plus that 22, so my other value is what? 202? And then plus 360k. Fred, did you have a question?
Yeah, so you just rounded it from 21.8 to...
Yeah, because I asked for the nearest whole degree. How are we doing? Okay.
That 180 and the 22, that's your... How did that get you back to the x-axis?
So I know that sine is negative, my outputs are negative in 2 quadrants, 3 and 4. That negative 22 is definitely in quadrant 4, but I have to get that, I use the 22 then as a reference angle, and I add it to the 180 to get me into quadrant 3. So what this one question is doing, it is testing your understanding about inverses, it is testing your understanding about coterminal angles, and it's testing your understanding about reference angles.
Did you draw that reference?
Yeah. So this is where negative 22 is. But if I put in my calculator this angle, which happens to be 202, and the way I found that was 180 plus, I make that 22 my reference angle. So if I put in my calculator 202, I should get approximately, because I am asking for rounding here, I should get approximately negative 0.372. So this one question is testing 3 different concepts, and something that looks pretty straightforward actually is testing 3 concepts. Do you understand the coterminal part? And that's this. Do you understand that when you do inverses, which quadrant are you in? And then do you understand reference angles? That's that part of it. So this is one question that's testing 3 concepts. Yes? So the reference angle is always the shortest distance from the terminal side to the x-axis. And it's a distance thing, so they're always positive. So if my angle is negative 22, my reference angle is 22. That's how far I need to come back to distance-wise in rotation.
What's the 202 doing for us?
In your calculator, Fred, do the sine of 202 degrees. So there are two places that I'm going to get a negative 0.372. It's going to be at 202, and it's going to be at negative 22. So we have to find both of them. If we're on the unit circle, it's pretty straightforward. We just look for those values. But if we're not on the unit circle, something like this, it is testing a lot of concepts in one small, simple question. It looks simple, it's small, but it's testing 4 different concepts in there. So it's not a bad question to ask. Moving on. So here's the summary for sine. It says all of my answers, or all of my signs, sine of the angle has to be in between -1 and 1. And I have to make sure that I slap on my coterminal angle 2 pi k or k 360. Depends on if I'm in degrees or radians. If it's equal to 0, then I just know it's multiples of pi. If it's equal to -1 or +1, then it's going to be multiples of pi over 2. If it's greater than 1, then it's a done deal. So if I'm asking you to find the sine of x is equal to 3, because that 3 is not in the range of sine, I say there's no solution and I walk away. Does that make sense? Because it's not in the range. And if you try to put that in your calculator, try to do the sine inverse of 3. Go ahead and do the sine inverse of 3, and it's going to say, I don't like you very well. Outside the domain, syntax error, whatever it does. It says, that's the calculator way of saying, I don't like you very well. So tangent is different. Tangent's range is everything. So if you get numbers outside of -1 and 1, then you get an answer, because the range of tangent and cotangent is everything. So if I asked you to find the tangent of x is equal to -1, all real numbers, how would you do that one? I'm going to use the unit circle. So where are my x and y exactly the same but with opposite signs? Which quadrants and what angles? 2 and 4. So my answer to this one would be x is equal to 3 pi over 4 plus 2 pi k and 7 pi over 4 plus 2 pi k. Now, if I asked you to find the tangent of x is equal to 7, rounded to the nearest degree, you're going to get your calculator out and give me that answer. So the tangent of x equals 7 when x happens to be 82 degrees. Unlike sine and cosine, I can't do sine and cosine is equal to something larger than 1 or less than -1. So where else is this happening? Quadrant 4. So how do I find the angle down in quadrant 4? What is my reference angle? 82. What am I going to do with that 82? Well, that will get me down in quadrant 4. If I do 360 minus 82, I'm going to get in quadrant 4. So I'm going to add it to what? 180. So what's 82 plus 180? What is it? We don't math today. Should only be in quadrants 1 and 3. Because that's where tangent is positive, is 1 and 3. Tangent's negative in 2 and 4.
Which one is quadrant 1 and 3?
And because tangent is positive, the answer for tangent is positive in two quadrants, 1 and 3. So I have to be in 1 and 3. Tangent is negative in quadrants 2 and 4. So I need to be in 2 and 4 for the first example, and 1 and 3 in the second example. But here's the thing about tangent. That's why we like tangent, but we don't like tangent. It's a love-hate relationship with tangent. My tangent has period of what? Pi. So this first one I could have just simply wrote as 3 pi over 4 plus pi k, because it has period of pi. I could have done the same thing here. X is equal to 82 degrees plus 180 degrees k, because it has period of pi. Those two numbers, 82 and 162, are 180 degrees apart from each other. Just like 3 pi over 4 and 7 pi over 4 are a distance of pi from each other. So with tangent and cotangent, you don't have to break it into two. You only have to figure out one angle and then put on its period. All the rest of them are period of 2 pi, so you do have to add plus 2 pi k. Yes?
Wouldn't it be wrong if you gave both?
No, absolutely not. No. So if you want to give me 2 every time, I'm good with that. Absolutely good with that. But if you don't want to, then you can combine it into 1. And that's only true for tangent and cotangent, because they're the only ones that have period of pi. It's the only ones you get to do that with. Okay? So when we are solving trig equations, which is where we're going to, the first thing we need to do is know the solutions of sine, cosine, and tangent on the unit circle. So that's what we started out with. If we can, we want to isolate the trig function. And we will have to use identities to do that. These get identities. These equations will get your understanding of identities. It will get your understanding of algebra in and of itself. It will get your understanding of inverses, coterminal angles, and reference angles. So these equations get a lot of topics covered for understanding. If you can use an identity to simplify it, you will. If the identity doesn't help you simplify it, then you won't. If it's a quadratic type, you're going to treat it as such. So if you have the opportunity to do some of those, there were quadratic types all over those identities. Should have seen quadratics all over the place on those identities. Sometimes you're going to have to square both sides. Sometimes you have to multiply by conjugates both sides. So everything that you learned in your pre-calc 1 and in fact before pre-calc 1 to solve equations will come now into play, but it'll have tangent and cotangent, and secant and cosecant. It'll have the trig functions instead of x and y. Yay! We're pretty excited about that. We're just so excited. Now, on these, I'm asking you to find it in a particular interval. Because I'm asking you to find this in a particular interval, I don't have to add plus pi k or plus 2 pi k. And if it's in this form, it's almost guaranteed that these are going to be on the unit circle. So which one of these would you like me to do? Do the last one. Okay. So for this last one, the first thing I want to do is isolate my cotangent. So I'm going to move the square root of 3 over. Oh, and actually I'm going to add, so I'm going to go one step first, is I'm going to add 3 to both sides. So I have the square root of 3, the cotangent x over 3 is equal to 3. So I'm trying to isolate cotangent. And then I'm going to divide everything by the square root of 3. So again, I'm isolating cotangent. So what I have, I'm just going to do it up here, is the cotangent of x over 3 is equal to 3 root 3. Now look on my unit circle where that is true. So where on my unit circle is that true? If I were to rationalize it, I'll rationalize it if that helps. If I were to rationalize it, I would multiply the numerator and denominator by the square root of 3 and cancel out, so it is the root 3. So that rationalizing that is root 3. So where is cotangent equal to root 3? Pi over 3? Pi over 3? Pi over 6. It's pi over 6. So my angle is equal to pi over 6 plus pi k. Now, I just said a moment ago that I don't have to do the plus pi k. I don't if my angle is just x. Is my angle just x? No, my angle is x over 3. Notice I just wrote down my angle as x over 3. I didn't do any kind of shenanigans of saying, hey, do I have to use a half angle or anything weird like that? No. Once I have my cotangent of my angle isolated, I just figure out where that is equal to the square root of 3, which is pi over 6. So that's how come when I did it, I wrote just, here's my angle, because here's my angle. I don't ever, if I can help it, use any half angle, double angle, or anything if I have just pi over 3 or pi over 7 or 2 pi, or excuse me, pi, x over 3, x over 7, or just 2x. I don't do any of those if I can help it. Because I know my cotangent of my angle is just happened to be called x over 3, is going to be true when I'm at pi over 6. Now I solve for x. How do I solve for x now? Multiply everything by 3. So I'm going to multiply this by 3, I'm going to multiply this by 3, and I'm going to multiply this by 3. My answer then is x is equal to 3 pi over 6 plus 3 pi k. 3 pi over 6 reduces, though. So now I ask myself, so my first angle is pi over 2. Is pi over 2 in that interval between 0 and 2 pi? Yes. If I add 3 pi k, is that in that interval? No. So this is my final answer. Because if I let k equal 0, I get my first one, which is in the interval. If I let k equal 1, I'm outside of that interval. If I let k equal -1, I'm outside that interval. So my answer does not have plus pi k or plus 2 pi k, but I do have to put in the values of k, 1, 2, 3, to stay in that interval. We'll pick these up again tomorrow. If you would like to start these, cool. Otherwise, we're going to do a bunch of examples tomorrow. Yes? Friday? Tuesday? Sometime after we graduate? It's Friday, yes.
There were some other examples from 10.6 or 5 that basically we solved those.
The ones that we're solving now?